Okay, so now we are going to get into our booklet that we just made and take notes on the first half of the book. So this is going to be page 24 in your notebook. You're going to title it Key Features of a Quadratic Function, which is exactly what the book was called. So all of those notes, all of those pages are going to be on one page in your notebook as this foldable. So we're going to turn to that now and get started on the inside. We're going to come back and do the front page at the very end. Okay, so this is where my booklet is going to get glued in. I haven't glued it in yet because I know that I still have to write on it with you guys. And it's easier for me to write on it when it's not glued in because the spiral messes me up. But this is going to be the page that gets glued on. You literally just put it on the next page. It should come right after solving for roots. Once you've got it in factor form, how we set them to 0 and solve, and then moving into key features. So we've been looking at quadratic functions algebraically. We can always tell that it's quadratic because it has a square with it. And we can take those quadratic functions and we can factor them out and solve for our roots. A root is just a place where your graph would cross the x-axis. So where your y value would be 0, you'll get some sort of number for x. So when you were solving for those, you would get x equals a number, and then you would get another one, x equals a different number, because each factor was set to 0. So we're going to look at some of the key features when we start to graph. And all of the stuff that we've been talking about in the equations should make sense when we look at it on a graph as well. So we'll fill this out, the front page, together at a later date. Once you've glued together your blank pages, when you open it up, you should go directly to page 1 and page 2. So we're going to start here with these two. Let me make my folds appropriate. Bit much right there. Okay. Intercepts, maximum, or minimum. So those are the two things we're going to talk about first. I highly advise using different color highlighters or different color pens to do this, especially when we start putting it all together. It's going to get confusing. So your intercepts, this is literally just like we've talked about with a linear equation. An intercept is where it crosses the axis. So you can have a y-intercept. It's where you're going to cross the y-axis. And an x-intercept, where you cross the x-axis. So when you're finding the y-intercept, your x will always be 0. So 0, 4 would be 4 on the y-axis. 0, 8 would be 8 on the y-axis. Because again, when that x value is 0, you're right here. You haven't gone to the left, you haven't gone to the right, you're right here in the middle. So because the x value is 0 and it doesn't send you left or right, any one of these numbers, if you go up 4, up 10, down 5, you're going to be sitting on that axis. So as long as your x value is 0, you'll be on the y-axis. That will be your y-intercept. The x-intercept is the exact opposite, but the same concept. It is where your graph will cross the x-axis, meaning that your y value will be 0. In order to sit on the x-axis, your y value has to be 0. So if you start in the middle here, and your x value tells you to go left or right, like 5, 0, then you can't go up or down or you'll no longer be on the axis. So your y value can't be a positive number and it can't be a negative number. The only value that your y value can be is 0, so that you'll stay right here. You can move left or right, but you cannot move up or down to stay on this axis. So 1, 0, 5, 0, 10, 0, all of those will have a y value of 0. Now, when we graph these quadratics, they are parabolas. They look like U's or an upside down sad face. They can sometimes have just one intercept or two intercepts. It just depends on where the graph is sitting and how that works. So if we look at these 4 examples, let me zoom in for you. Okay, we're going to find the x-intercepts and the y-intercepts. So we're literally, I just want you to put a dot where the graphs touch the x-axis and where the graph touches the y-axis. Those are your intercepts. Where is this graph running into or intercepting the axes or the axes? And you've got an x-axis and a y-axis. So You're looking for both of those right now. Those are your intercepts. On this example, we have one here, here, and here. And in a second, we're going to come back and we're going to find the coordinates of these. Again, where does this graph, this U that's being graphed, cut through the x-axis and the y-axis? Here and here, and this is my x-axis and my y-axis. And for this last one, we have here, here, and here. So now we need to actually say, well, what are those points? Like, what is the intercept? I mean, I can physically see the dots, but what are those values? So we're just going to go in. We know that it tells us up here, for a y-intercept, the x has to be 0. So in this ordered pair, I already know that x is 0. I just have to figure out what my y value is. But what number is it sitting on the y-axis? 10. And for my x-intercepts, my y is going to be 0. So for both of these, I'm going to have a y value of 0. I already know that. Now I have to figure out what that x value is. That looks like 1 and 5. So this one goes over 1 space, this one goes over 5 spaces. Okay, so these are my x-intercepts, and this is my y-intercept. Over here, I would do the same thing. If these are touching the x-axis, then those are x-intercepts, and I know that my y value is going to be 0. This is -2, 0, and this is +4, 0. And then what about this one down here? Well, that's a y-intercept. It's cutting through the y-axis, which means I know that x value is 0. Just to figure out what that y value is, and it looks like it's down 16. So that would be my y-intercept, and these would be my x-intercepts. Remember, at most you can have 2 x-intercepts. I want you guys, I'm going to leave them here. I've already dotted them for you. I want you guys on your own when you turn this in to write down the coordinates for these points and write down if that point is the x-intercept or the y-intercept. And so that's going to be your practice with intercepts. You're going to do these last two on your own. I've already dotted them for you. Second page, we have maximums and minimums. This is literally just like what it sounds like. The highest point or the lowest point. So your maximum is going to be the largest y value when the parabola opens down. So right there, the lowest value on that u. I'm sorry, I just drew that backwards. When the parabola opens down. There we go. I was like, that's not maximum. So it's like the tallest, the max height that this parabola can have. And it's your point. It's that center of the U. And it's either going to be your maximum or your minimum. So if it's opening to the bottom and your point is at the top, it's going to be a maximum. If it's opened up top and your point is down at the bottom, then that point is going to be a minimum. So the minimum is when it opens up, so the top is open, that's going to be the lowest point. It's also called the vertex. So if I say, what's the maximum or the minimum of this parabola? Whenever you tell me that point, you are also telling me the vertex. The vertex is the highest or lowest point on a parabola. So they are the same thing. They are literally the same. So let's look at these examples again. I'm going to give you, I'm going to give you the first two, and then the second two I'm going to want you to do yourself. Okay, technical difficulties. So again, let's identify those points. In this parabola, the point of my U is right there. In this one, it's right here. In this one, it's up top. And in this one, it's up top. So you're just finding that middle point. And again, these lines are kind of hard for you guys to see, so try your best here. I'm actually going to do these two because these two have better lines for you guys to do on your own. So if I'm looking at these two, this is a minimum value. And the vertex is, we have to plot this point. It looks like I go over 3, 1, 2, 3, and down 8. So we're going to say over 3, down 8. So that would be to the right 3 and down 8. That's my vertex, 3, negative 8. It's also the minimum value because this parabola is sitting where the point is at the bottom. Now, if I were to do this example, I had to add some lines there. It looks like this point is a maximum value. And the vertex is left 6, up 2. So it's left 6, up 2. So that point is the maximum point in this graph. There's not going to be a point that's ever going to be higher than this point. It's the maximum point, but it's also the vertex. It's the middle, highest, or lowest point. That is what the vertex is. This vertex happens to be the maximum point. This vertex happens to be the minimum point. That just deals with the way that your parabola opens. So you guys are going to plot these two. Tell me what the coordinates are, and is it the maximum or the minimum point? So is that vertex the highest point, or is it the lowest point on your graph? You'll do those two on your own. And then our last 2 pages for today, like I said, we're doing the first 4 pages, is axis of symmetry, which is exactly like the vertex. Instead of a point, we just draw a line. And end behavior. So these 2 pages are also fairly easy. So axis of symmetry, if we start here, it tells us at the top, axis of symmetry is the vertical line of reflection and can be written in the form x equals a number. So put a number symbol there. It can be any number for your axis of symmetry. It just depends on where it is. So the axis of symmetry, the x value should be the exact same as the x value in your vertex. So right here it says the axis of symmetry is the x value of the vertex. Because again, they're shared. So if I were to draw the line of symmetry right here, I'm going to get a ruler to make sure that I do it nice and straight. Really cut through the middle. Right there is the axis of symmetry. So if you can find your vertex, you just draw a line through your vertex. Because the vertex is the highest or lowest point, and since we're doing a parabola, it's symmetrical. You know, however it moves on the left side is exactly how it moves on the right side. Your U isn't going to be lopsided. So if you find that middle point, whether it's the highest or the lowest point, if you can find that vertex, your axis of symmetry runs right through the middle. And again, this side of the graph is symmetrical to this side. So if you end up graphing and you know this is your vertex, and you know this point is 1, 1, then this point is going to be 1 over and 1 up from the middle as well. Whatever happens on this side happens on this side as well. It's not going to be in a crazy different spot. So for this first example, again, it's hard to see, but between 0 and 5, the middle here is 3. 1, 2, 3, 4, 5. So our vertex is 3, negative 8. So our axis of symmetry is 3. Again, this should be the same as the x value in your vertex. So if we go over 3 and down 8 to get to the vertex, well, where is that line on the x-axis? It's at 3, because we went over 3 to get to the middle right here. I'll do this one, and then leave these 2 for you to do, because again, they have better lines for you guys. So this one down here, it looks like the vertex is right here, which is sitting above negative 6. And that looks like 2.
hard to tell. So if I can figure out that my vertex is left 6 up 2, remember x values come first. If my vertex is left 6 up 2, then my axis of symmetry is x equals 6. It is the same x value as my vertex. You're just looking at where it cuts through the middle of this parabola. So an axis of symmetry should match up to the x value in your vertex. Axis of symmetry is super easy. You guys do these two. I'll put the points here for you. So this minimum point and this maximum point. Find that coordinate and draw the axis of symmetry cutting through the vertex. End behavior, it basically just describes what's happening at the end of your graph. So we know that the vertex is the center of our graph, and it's either the minimum point, as these two first examples show, or it's the maximum point. It's either the highest or the lowest, but that is the dead center, it's the middle, and that's where the axis of symmetry cuts through. And so we know whatever happens on one side happens on the other. They're both moving the same way. Are they either moving up and away or down and away? And they're always going to be moving out. You're never going to have a U that all of a sudden comes back in and crosses. They're always going to keep spreading further and further out the bigger you make it. So the end behaviors can be described as the following. X goes towards negative infinity. You would write it like this. X goes towards positive infinity. So this is positive infinity. So this end is going to positive infinity for the x values. Meaning, if you look at every single point on this graph, this x value is 4, this x value is 4.1, this x value is 4.2, this x value is 4.5, this x value is 5, this x value is 5.5, and it's just going to keep using every single x value, slowly but surely, as it continues to go up because it's also going out to the right. And so it's going to end up using every positive x value. This one, however, since it's going out to the left, as it gets bigger, we'll continue to use all of the negative numbers on the x-axis. So this would be x is moving to negative infinity. So what we're looking at is what's happening to the y values when the x values are doing this. And then if the parabola opens up, the y values are going towards infinity, positive infinity. Y equals positive infinity. Because again, starting from this point, every single y value is going up. We're using points up here. We're not using any points down here in the negatives. We're not going in that direction. So we're moving up. We're moving towards positive numbers. So it's moving in the positive direction. If the parabola opens down, like this example right here, every single y value that we're using is getting smaller and smaller and smaller until it starts to become negative values. So it's going to use it's going towards negative infinity. And so all you do is based on if it's opening up or down, you look at those characteristics and you describe what the end behavior is going to be. So let's look at these two because, again, the lines are harder for you to see. Not that that matters on these. Let's look at this side. So we're looking at the end behavior of both sides. Again, what's happening with this end and what's happening with this end, the behavior of the ends. Well, for this end, if we look at what's happening as we go up and off this graph, it's not only going up, but it's also going to the left. So if it's moving up, that means that our y value is going to positive infinity. So for this side, we have our y value is going to positive infinity. Look at that, it's moving up. If I were to keep graphing, the graph would keep going in that direction. That's a little too slanted, but you get the point. So the y values are going to keep increasing. Those are positive numbers forever and ever. But what's happening to the x values? From this point to this point, I'm actually further left, right? To get from here to here, I go left. I am going up. I am using positive y values, but my x values are actually getting lower. My x value here looks like it's 1. My x value here is clearly 0. My x value here is negative 1. So as I keep moving left, I'm actually going to the negatives for my x values. So as the graph opens up and goes to the left, that's positive y values, negative x values. On this side, however, If we look at our y values, it's opening up, which means our y values are going to positive infinity. It's going to use every positive number that there is forever and ever. And from the vertex to this end point, you can see that it's also moving to the right for my x values. My x value here is probably 3. Here it's 5. Here it might be 6. Yeah, probably 6. So these are going up in the positive direction. So one end is going positive for y's, negative for x's. Another end is going positive for y's and positive for x's. And then you guys are going to do this one for me. What's happening on this end to the y values and the x values? What's happening on this end to the y values and the x values? So you should write y, x, and then do the other side, y, x. As the y's go in what direction, the x's go in what direction. Same thing for both ends. Let's look at this one. Look at these end behaviors here. What's happening? So on this end, it looks like it's going down and also moving further to the left. Like from this point, from the middle, from the vertex, going to this end, my x values are going further into the negative. So on this one, as my y values go down, right, I'm moving down. I'm going down the y-axis. From my vertex to the end, I'm actually moving in the downward direction. But from the vertex to this end, I'm also moving a little bit further left. So my x's are also going in the negative infinity. Right, left is negative. These are all negative numbers. So if you're moving anywhere in this direction, it's negative. So as I keep graphing this, I'm going to keep going negative and negative and negative. Now from the vertex to this end behavior, my y values are still going down. I'm still opening downwards. But from the middle to this end, it looks like my x values are getting bigger. They're moving into the positive direction. This starts at -6, but over here, if I were to plot this point, that would be +1, -20 something. So my x values are actually going positive. So I'm moving in the positive direction. So one end is negative y's and negative x's. The other end is negative y's, but it's moving in the positive direction on this x-axis. X is left and right. So from this point, I'd have to move right to get to that end behavior, which is positive. From this point, I'd have to move left to get to this end behavior, which is negative. From this point on the y-axis, to get to either one of these end behaviors, I have to go down. So the y is negative infinity for both, because from the middle to the ends, I'm going down on the y-axis. But for this one, like here, from the middle to the ends, I went up for both of them. So both end behaviors had positive infinities for y. Now from the middle to one end behavior, I went to the left, which is a negative x direction. And from the middle to the other end, I went to the right, which is a positive direction. So if you want to do it that way, you can make your pencil line up with the axes and see which direction you're actually moving from that vertex to that end behavior. And you've got two ends for each graph. So you're going to do this one and this one now. And that's it. That's the first 2 pages for today. I know that was a lot, but I just want to make sure that you get it. We've got to do the other 4 pages tomorrow. So make sure that you have this done or else you'll be confused because, again, we're building on everything. So just to clarify one more time, you are going to do these 2 on the first page, just plotting the coordinates and whether or not they are x-intercepts or y-intercepts. These 2 on the second, telling me what that point is and if it's the maximum or minimum point. These 2 on the third page and just telling me what's that point and where is the axis of symmetry. And these 2 telling me what's the end behavior for each end on these 2 graphs. And that is all you have to do for today for your notes.